In our next set of videos, our objectives are to use the sine and cosine ratios, find the sine and cosine of angle measures in special right triangles, and to solve some real-life problems involving sine and cosine ratios. Using the sine and cosine ratios, the sine and cosine ratios, which are usually, sine is usually abbreviated with SIN. That's how you'll see it on your typical calculator. And cosine will be abbreviated with COS. These are trigonometric ratios for acute angles. So when you're dealing with your right triangle, you are not going to be dealing with the 90 here. You're going to be dealing with the two small angles, the two angles that are less than 90. So in this triangle, you could find the sine of angle B or the cosine of angle B. You could find the sine of angle A or the cosine of angle A. So the sine and cosine ratios are trigonometric ratios for acute angles that involve the lengths of a leg and the hypotenuse of a right triangle. Sine and cosine ratios. So let triangle ABC be a right triangle with acute angle A. The sine of angle A and cosine of angle A, written as sine of angle A and cosine of angle A, are defined as follows. The sine of A is just the length of the leg opposite angle A. So if here's angle A, this would be your leg opposite angle A, which is BC, over the length of the hypotenuse. Hypotenuse is always directly across from your right angle. That's AB. So the ratio of BC over AB, this is your opposite over your hypotenuse. That is how you define the sine of an angle, opposite over hypotenuse. The cosine of an angle is the length of the leg adjacent to angle A. So here's angle A. This is my adjacent side right here. So remember, my adjacent side will always be touching my angle right here. It'll be the segment that comes to that vertex point right here that's not your hypotenuse. And then in your denominator, once again, you have the hypotenuse. So the cosine of angle A is just AC over AB, that ratio. Remember that we have that neat little saying with SOHCAHTOA to help us to remember this. So we already talked about tangent, the TOA part. Tangent is just your ratio of your opposite over your adjacent. Sine, once again, O and H, opposite over hypotenuse. Cosine, adjacent over hypotenuse. If you're ever struggling to remember what words go with what ratio, always think back to this SOHCAHTOA idea. And this symbol right here, this is a Greek letter theta. It just holds the place of an angle. You'll see that typically used with sine, cosine, and tangent. So with the sine of theta, cosine of theta, tangent of theta, I can see that my ratios are as follows: sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. And this down here pretty much says the same stuff.